In today's topic, we will discuss about circuit diagram of a DOL starter. Before starting this topic, if you have not watched my previous video about DOL starter, please watch the video for better understanding. The link to the video is provided in the description box, so please check out the description box. Now let's quickly get back to our main topic, that is circuit diagram of a DOL starter. Basically, in any starter, we have power and control circuit. What is power and control circuit? Power circuit, the circuit which helps in providing power to the motor, is called power circuit, and control circuit is the circuit which helps in controlling the power to the motor. Here, controlling the power to the motor is an important point. With the help of control circuit, we are controlling the power supply to the motor. We are not directly controlling the motor. We are controlling the power supply. Before drawing the circuit of a DOL starter, let's understand components used in a DOL starter with their respective single line diagram. These are the components used in an DOL starter. Here, this is a 3-pole MCB. It looks like this, and we will connect main supply to these terminals, and the output is coming out from these terminals. Okay, these three terminals are connected to the line, that is R, Y, B, and the neutral line runs in common. The single line diagram of a 3-pole MCB looks like this. Because it's a 3-pole MCB, we have 3 poles Next comes the power contactor. A power contactor is a very important part in a DOL starter. The power contactor consists of L1, L2, L3 terminals and T1, T2, T3 terminals. L1, L2, L3 refers to line 1, 2, 3, that is R, Y, B, and T1, T2, T3 terminals are connected to the motor's R, Y, B motor's terminal box, that is RYB of a motor's terminal box. So the power contactor single line diagram looks something like this. This is L1, L2 and L3, and this is T1, T2 and T3. This is the very basic and very vast representation of an power contactor. There's other forms of representations also, but mostly this representation is used. Next comes the overload relay. Overload relay is the protection given to our mission. So it protects us from overload, that is indirectly it's protecting us from over current. Because when the load increases, gradually the current also increases. So it's an overcurrent protection given to our motor. The single line diagram of overload relay looks like this. These are the terminals connected to the contactor, and these terminals are connected to our motor. Next comes the 3-phase induction motor. That is simple. Motor and it's 3-phase AC. Okay. This is a single line diagram of a 3-phase motor. Similar to 3-pole MCB, we have 2-pole MCB. Because there are only 2 poles, we have only 2 poles, and the diagrams looks same. This is the diagram of a 2-pole MCB. Next comes the control transformer. We are using this transformer as a step down transformer. Because we are stepping down the voltage and giving it to the control circuit. So step down transformer or any transformer looks like this. This is the primary side and this is the secondary side. Stop push button and start push buttons both are basically NC and NO contacts. That is, stop push button is always an normally closed contact, that is NC contact, and start push button is always a normally open contact. Whenever you press the start push button, it will turn into normally open, and whenever you press this start button, it turns into normally closed. The single line diagram of a stop push button looks like this, and the single line diagram of a start push buttons looks something like this. This is and this is stop. Now let's quickly draw the DOL starter circuit diagram by using all those components which we have learned till now. Initially, let's draw the power circuit and then connect the power circuit with the control circuit. We have a three-phase supply R, Y, P phase. This is R phase, Y phase and P phase. From R phase, we're taking this up, and P phase. These three are connected to a 3-pole MCB initially. The symbol of 3-pole MCB is like this. I have explained before, right? It looks like that. From 3-pole MCB, it's directly connected to a power contactor. From the power contactor, it goes to an overload relay. This is an overload relay. From an overload relay, it is directly connected to a 3-phase AC motor. Okay, this is 3-pole MCB. This is a power contactor C1, and this is overload relay. Overload relay is giving protection to the 3-phase motor. Okay. Now this entire circuit is known as power circuit because it's providing power to the 3-phase motor. Now let us take power from this power circuit and let's control the power going to this motor. So we are taking two lines. You might take anything R, Y, Y, B and B, R, anything, and connecting it to a 2-pole MCB. This is a 2-pole MCB, and I'm stepping down this voltage by using a control transformer. We are getting 415 volts AC here, and we are stepping it down to 230 volts AC. This is a control transformer, and this is a 2-pole MCB. From the step down voltage from the secondary side of the transformer, we get 2 wires. So we are controlling the motor in such a way that first we are giving an normally closed switch of OLR. Overloads relay normally closed switch is placed here. This is 95, 96. Don't go with the numbers because these numbers are ANSI codes given to the OLR relay. On the OLR relay, this is the overload relay. If you see, we have 4 points. These 3 are connected to the motor directly, and these points are NO-NC contacts. So we have 2 contacts of NO and 2 contacts of NC. Normally closed contacts of OLR relay are always 95 and 96 contacts. This is according to the ANSI code. So I hope you understood. So we are taking 95, 96 normally closed contacts of OLR. After normally closed contacts of OLR, we are connecting a stop switch. Remember, I have already told you stop switch is always normally closed. After the stop button, we are connecting it to a start switch. This is normally open start switch. From the start, we are giving supply to the C1 contactors A1 and A2 terminals. That is auxiliary coil terminals of A1, A2 contactor. See, in a contactor, we have, as I have told you, contactor looks like this for your better understanding. We have, this is L1, L2, L3 and T1, T2, T3 of a contactor, and all of these are connected to a plunger, and here we have our coils A1, A2 contacts. As soon as this A1, A2 contacts of this coil get power, this gets magnetized and it pulls this plunger back. When this plunger is pulled back, the position of this comes to here, and it will close the circuit, and the power from L1 flows to T1 and it will become a closed circuit. Before it is an normally open contact. After giving power to A1, A2 terminals, it will goes to normally closed contact. So this is the working of power contactor, and A1, A2 terminals, auxiliary terminals are very important. Without giving power to this auxiliary A1, A2 contacts, that is, without giving power to this coil, we cannot operate an contactor. So here we are giving power to A1, A2 of the contactor C1. We have drawn the circuit. Let us just quickly understand how this circuit is working. We have three phase, very good, and from three phase we are getting power till here, and the voltage is stopped over here because there is no path to flow. As soon as you close this, switches, the voltage start flowing from here and it will stop till here because the coil C1 is not energized. You just follow my red path so that you can understand. The C1 coil, the C1's A1, A2, see A1, A2 of C1 should be energized so that these contacts change from normally open to normally closed. These are currently normally open contacts. These are normally open. A1A should get power to close these contacts, and the voltage will pass after closing the contacts. So the voltage is stuck till here. Our motor is still not running because there is no voltage flow. Then we have taken two other supplies to the two pole MCB, right? The supplies are stopped till here. We will manually close the MCBs. MCBs are closed, and the power comes to our transformer. 415 volts power is coming to the transformer. It flows in the transformer primary, and in the secondary we get 230 volts. The 230 volts is coming from here, and you'll see 95, 96 normally closed. The power flows and goes to stop switch button. Stop switch button is also normally closed. So the power keeps on flowing, the voltage keeps on flowing and stops till here because this is normally open switch. As soon as you press this normally open switch, this will get closed and the power goes to C1 of a contactor. Now your A1, A2 terminals of the contactor C1 is receiving power. This coil gets energized and it pulls the plunger back. When the plunger is pulled back, this normally open will close to normally closed. Now this contactor is closed and the power starts flowing to the OLR and to the motor. Now your motor is running. There is a catch. The catch is, as soon as you pull your finger back, because these are normally closed and normally open push buttons. These are push buttons. Okay, these are push buttons. As soon as you pull your finger back, if you pull your finger back, these push buttons will again come back to their original state. The original state of start push button is normally open. So when you push it, it will goes to normally closed. And when you take your hand back, it will come back to normally open. So as soon as you take your hand back, again, as soon as you take your hand back, this will become open. And the voltage will stop over here, and your A1, A2 contacts are again de-energized because the voltage is stopped till here. It will come till here and it will stop because this is open. Now to complete this circuit, to make it a complete circuit, we have To connect and latching contact, here comes the picture of latching contact. A latching contact is also an normally open contact. This is called latching or holding contact. This is called a holding contact. A holding contact is also an normally open button of, we are connecting a holding contactor of C1 contactors, normally open contacts. That is, in this, see, this is a power contactor, right? In this power contactor, these are L1, L2, L3 and T1, T2, T3. We have other three terminals. In these three terminals, we have NO and NC. Same like this OLR, in this contactor also we have NO and NC terminals. So from this NO and NC terminals combination, we'll take one normally open terminal, and the normally open terminals ANSI code will also be always be 13 and 14. We'll take 13, 14 contacts of this normally open terminal of C1 contact. Please don't go with the number 13, 14, that is normally open contacts of C1 contact. Now again follow my path. This time we'll go with the green color. Yeah, follow the green, sir. First the power comes till here and waits. Same like before, the power waits here. As soon as you close this, the power starts flowing and stops till here, because your contactor is not yet energized. Okay, please follow the green line. Okay, green line. Now you're taking two other supplies, right? So it comes till here and wait. As soon as you close this again, it will start flowing till here. It will goes to the primary of the winding, secondary side, it will get step down and it will come to 95. Check here, it is normally closed contact, so it passes from here. It again waits at stop. It's normally closed. It passes till here. It stops here, as well as the power flows here and stops here. Okay, now see, the voltage have two paths. Okay, the voltage have two paths. So it's stopping here. It's stopping here. You will now push the start push button. As soon as you push the start push button, it will go till here. Even A1, A2 get energized. As soon as A1, A2 gets energized, this coil gets energized and it acts as a magnet and pulls this plunger back. Once this plunger is pulled, this will get closed. When this is getting closed, that is, I'm referring, this is C1. Okay, don't get confused. So as soon as A1, A2 gets supply, this contactor closes. When this power contactor closes, the power starts flowing, and this is our OLR. It flows through the OLR and our motor. And now our motor is getting power and it's fully functional. The story is not end. Now when the C1, C2 gets energized, all the terminals in this interchanges. I mean, all the NO changes to NC and all the NCs changes to NO. Okay, because you have seen, right, this plunger is getting back. We have an open, it's getting closed, and if this is closed, it's getting open. So here we are considering C1 contactors NO terminal, right? This NO changes to NC and this changes. When this gets closed, path flows like this. The voltage path flows like this. Even if you take your finger back, it will changes back. This push button will retain its previous state. Even though it's retaining its previous state, the voltage flows in this path, and your A1, A2 auxiliary terminals will always have supply unless until you press this stop push button. Okay, as soon as you press the stop push button, once you press and leave button is normally closed. As soon as you press it, it will change to normally open, and as soon as you release it, it will come back to normally closed. So you are pressing it once and releasing it. So it will partially open the circuit. As soon as the circuit is opening, your voltage will struck over here and your C1 contactors A1, A2 get de-energized. As soon as this A1, A2 gets de-energized, this will again open, so that motor does not receive power and it's not running, because these contact C1, the contactor gets open. The second case, if there is a fault in OLR, overload relay, if you by any chance your motor is drawing over current That is, your motor is taking overload, it will draw more current. If your motor is drawing over current, this OLR gets activated. When this OLR gets activated, it is similar to a contactor. When this OLR gets activated, its normally closed switch changes to normally open. When this changes to normally open, your voltage is stopped over here and your motor is protected from overcurrent, because this will get opened. As soon as this gets opened, the voltage stops here and your A1 A2 terminal will not receive any power, and your C1 contactor de-energized and your C1 contactor is again open, so your voltage does not reach your motor. This is the protection given to the motor. So OLR is always placed before your 3-phase induction motor. That's all for today's video. Hope you liked it. Please do like, share, subscribe my channel. This is Sandeep Shatri signing off.